Hello everyone, welcome back today. So we are smashing through core RHCSA topics in our series. So today you will master Linux user management and the file links, like how files are storing the metadata and how they are linking to the each other, and their ownership also we will look into. So let's jump straight into the terminal. So this is the Linux box we know, right? We already set up in our previous video. So we need some kind of identities to log in, right? So here you can see that I have logged in with my Ansible user, right? Or maybe you have a different user which you already created and you have logged in. But now the thing is how my Linux box knows, okay, this user, whether it is able to log in or whether I should assign or allowed to log into the box, what are the other entities I need to create, because if I'm logging in, right, so obviously there are some kind of home directory is assigned where I can store my personal file related to my project or everything, right? You can see the ownership and permissions. This thing I think we have already discussed, but again I will touch all these things. What are those, right? So the file stores user account information, right? Which is that file? So we have something called passwd, right? So passwd is the file which stores all the identities created locally in your Linux boxes. Usually it has contains a 7 fields. So you will see the username for this, right? Then you have this X. X means is something that okay, it has a kind of password is associated with this. Then you have this 0 is your user ID, and this is your group ID. This is the kind of what you call it, your home directory, and this is your home directory, and this is your shell, right? So this is something that we have already done, right? And it is additional, like if you are part of any group or something. So that's what we have this, right? So in our notes also we can see that UID is 0. So root user is the main user, right? That is the highly privileged user which is already created in the system when you install your system. So you can see this root user is created with the UID called 0. This is its primary group, this is its secondary group, and some Linux context, right? So we will discuss later in this course. So just forget about that. But yeah, this is the main user. So you can see that the super user and the system administrator with unrestricted access to all files and command. That's what, because it is a super user of your system, right? So system user accounts created automatically by the OS on run specific services background daemon Apache, Nginx, MySQL, or any other daemon if you are running in here, right? But regular users, those are the standard accounts, right? Humans accounts, those will not have a system-wide access. We need to maintain that access via something called sudoers file, which we will talk later. But as of today, we will understand only what are the users and groups. Now we have the types of groups in Linux, right? So we have two types of group. One is something called the primary group, and the other one is the secondary group, right? So primary group, generally we see that it where the user belongs to that primary group, and most of the cases you will find that it is the same group as the username, right? There are scenario where we have the different name for the primary group, but usually created with the exact same name as the user, right? That's what we are doing. Secondary group is a kind of supplementary group. Group is used to create later to grant them additional permissions, right? We will talk about, so maybe you will understand what are those, but as of now we will understand only we have two types of group. One is the primary group and the other one is the secondary group, right? So apart from that, we have few critical configuration file where Linux store all these information, like we talked about the etc passwd, shadow, and the group, right? So let's see all these files now. Let me cat the passwd again. So here you can see that this is having the all users, whatever the local users has been created in my system. We have this root user, we have this Amit user, we have this Ansible user, we have the Path for Cloud user, right? We have Node Exporter, Grafana, Prometheus, Nginx, right? So we have many local created groups already there, right? And you need to understand these fields, right? So first one is the username, then it is saying that okay, you have the password set, then UID, GID, and the comment field, and then your home directory and the login shell, right? So guys, this is the comment field, right? Like just you are putting this, like it is a Grafana user, it is a root user, right? So here it will not show the what do you call it, that primary group inform secondary group information, that will be in etc group, not here. So you can see that, right? So as of now, you can see that these are the groups. So if I see, so root user will not have any additional. Now wheel group will have the path for cloud, right? Similarly, we have the Ansible user, but that is not part of any uh, wheel group or maybe a super admin group, right? So how that will be able to become a root? So that we will talk about when we discuss the sudoers part. But you can see that whatever this, so wheel group is a kind of admin group. If you are a part of that wheel group, then you can run the command same as a root user, right? So this is a path for cloud, which is a local user, which is part of this wheel group. Then we have something called shadow file. So shadow file is having a little kind of these un like weird stuff, right? But this is not weird. This is the encryption form of your password, whatever that you have created, right? Let's say I have this my user, right? So this is the path for cloud user, and starting from here and till here, I have my this uh, encrypted password for my stuff, right? So here you can see. So this is the encrypted password, and it is also having a same stuff, some strange thing. So first you can see that it is starting from this $6. So $6 is saying that okay, what kind of like encryption you are using, whether it's a SHA 512, SHA 256, SHA 128, right? So whatever this SHA 128, 256, 512, those are a kind of algorithms, right? Maybe we'll touch those also in our security class. Then we have something called salt, right? So automatically it is adding some salt to just to keep your username differently, right? There might be a chances that both user will have a same password, right? But if we follow the same thing, then you can see that they will have the same encryption. And if you are smart enough, then you can just find out okay, this user is also having the same username and sorry password, and then you can log in with that account, right? So what Linux is doing, Linux is much smart than us. So what it is doing is it is adding some kind of additional salt, and it is creating, then using that salt it will create it, so you'll never know what that password is, right? So that is this Sedo file, right? In shadow file also we have few this. If I just say ch age, I'll explain this. What are these additional stuff, right? So this is the age of my like number of days since Linux epoch time, which is to be considered as a 1st January 1970, right? So this is what that then it is saying that last password change, and then we have the zero is that when your password is going to expire. Then you have this uh, password inactive, then you have the account expire, then you have the minimum number of days and everything. So this is how that you can set or create your account, right? You can set your all these parameter for your uh, local user, so that if you are creating a new user, right, so obviously you need to set some kind of this stuff, right? So what it will do is, let's say if I am going to create a new user, so for that we have command called user add, right? Let's see, user add. Let's say I'm adding a demo user. Fine. Now if I cat my passwd file and grep for demo, so here you can see that I have added, and automatically it has created this home directory and assigned this bash, right? So there are stuff which is there already at, we have the skull and the job d daemon, which is if you want that there is something needs to be added, so you what you can do is you can create this file skull, right? So this here you can create additional something, so whatever the file or the directory you are creating, automatically that will be created under the user home directory. And how this is being tracked, this is being tracked by the systemd temp files daemon, that will take care of all these stuff. Okay, so now I have done this, right? Let me set some password for this demo user. So passwd is command which needs to be run when you are setting or changing the password for a user, right? So passwd root user can run with any of the user, because root is a super user, right? But if you are a normal or standard user, then only you can change your password if you are not belonging to any kind of super group or some additional privilege, right? But root can do thing. So let me set this red hat at 123, red hat at 123. You can see that there is a warning called bad password. The password fails the directory check, right? Dictionary check. It is based on the dictionary word or something, right? Linux has its own standard policies, right? Which it's follow. If you could have done this with your normal account, so probably it will not allow you, because there we have the restriction. But being a super admin, it is just giving you a warning. But you can see that it has updated the successfully my user, right? Demo user was created. Now, if I check this demo user, so here you can see this demo user is the GID, and it is the part of only on it's already a group, right? We have something called group, which we have already seen. So we have a group called shared. So I want this demo user to be part of this shared group as a additional like the secondary group. So what we can do, user add command was the command to add the user, right? Passwd was to just to assign the password. User mode, right? User modification. So that is the short form for this user mode. Hyphen A will gonna append this, and capital G is for your additional group without removing them from the existing group, right? So what I will do is I will just say this will be part of something called shared, and the username is this one. Now if I run this, so you can see this demo user is part of this shared. If you cat the etc group also, so it is automatically added. You can edit this file and you can just directly go and add, right? But that is not the recommended way. Recommended way is using these utilities, like we have the user mode, right? So that's what that you can do. Now come back to that shadow file, right? So what is happening that as of now, if I just run chage-l demo user, right? So you can see that it is set to anything to never, never, never. But I don't want. What I want is like the maximum password the change that will be 90 days, right? Minimum days between the password change to your set the minimum day between the password change, right? So that you cannot use the old password for the same, right? And whenever what does the time like you will get the warning, okay? How many days that before you get the warnings that you want to, right? So what you can do, there is a yeah, there is one more thing. anytime if you are not able to call all these parameter and everything, right? So we have that dash dash help, right? Because see, Linux is having a vast, very, very n number of commands with n number of flags and n number of sub options commands, right? You cannot remember everything. You just remember that whatever the daily routine commands which you are running, right? But for the additional flags and everything, obviously you can take the help from this command itself. So we have understood, right? Dash dash help in our previous video. So just run chas dash dash help, which will give you this. So here you can see capital M is for max day, right? Set maximum number of days before password change to max days. Let's say I'm setting it to 90 days, right? Then this minimum days, set minimum number of days before the password change to min days. Let's say it is set to, I have set to 7 days, right? And I am setting it for demo user. Now if you check this, so you can see that earlier these two values were different, but now maximum number of days between password change is 90. That means that within 90 days it has to be changed the password. Minimum number of days between password change is 7. Like if you have changed or that you cannot use the same password within that 7 days, right? So these are the additional stuff. You can see the last day, set the last day of password change to last day, is expired date, right? If you can set it to 0, so obviously it will ask you to the first login. Inactive, if you want to make this user as inactive. List is just to list the information about this, right? So that is what that you can do. Let's say if I am doing this demo user, okay, let's try to take the session. Okay, it will automatically taking. So I will do one thing. I will go to the new. I will load, and I will change this to nothing, and then open demo user, and we have set red hat at 123. Right? You can see that I am able to log in. Now let's do one thing. Let's set it to 0 for demo user. And now if you list, so what it is saying is password must be changed. This is what that you can do. What uh, because most of the industry, right, there is very less you will find that these local accounts to be used. There may be some jobs, there may be some kind of automation you are using. There probably you can find these, right? But there also we never set this password expire because those are the automation job. There is no human intervention there, right? But still, if you have few users which are locally needs to be managed, so what you can do, being a system admin, you got a request, you will create a user, right? And you set some password, and that password has to be shared with your user, right? But what generally we do, we set this to 0. So what it will do is it will prompt the moment you log in, right? It will gonna prompt you for that, right? So what, let me take one more session and let's see if it is prompting us or not. So I will pass the password, and here you can see changing password for user, right? Warning, your password has expired because we have set it to that 0 days, right? So anyhow you have to change this, right? So that's the way that you will manage. Okay, so this is the user mode and group add and everything. Similarly, we have the command called group add, which will help you to add the new group. Group del is something where you want to delete, right? Similarly, we have user del. So these are the basic command. I'm not gonna tell you each and everything here. So let's do a file permission, right? So what is happening is whenever you have something, let's say uh, we have this negios directory here, right? So what you can see, mm, here you can see we have these 9 fields, right? What it is talking about, that the first three is RWX, which is a read, write, and execute. That belongs to your user. The second one is RWX. Here it is empty because we can see the dash that belongs to your group. And the last is other world, which is not a user, which is not a part of any group. Those users do what with these directory or file, right? So these are the just for the just like how the file permission works and everything. But we will talk all these in very much details. So every file and directory on a Linux file system assign a read, write, and execute bits to three distinct tier: user, obviously, group, and others. Every other user account on the entire system, right? Apart from that, files are identified with the inode, right? Because in Linux, everything is file, right? Whatever you see, what you run, everything is file, right? But if I run this, right? So here you can see if I run the same command with this, so here you can see it is not showing me anything, right? It is just showing me this, right? Or maybe you can just run this ls-li. Similarly, D is just to check the directory, L is just for listing and then the long listing on the same directory, and I is just to inside the directory. So here you can see that it has printed some few random numbers, right? What are those numbers? Those are the inodes, right? Because every file has an inode, right? Think of an inode as a kind of metadata passport for the file, right? It does not store any kind of file name or the actual data. Then what it is storing, right? It holds the file size, right? Whatever the file size we can see. It holds the owner and group permission, right? It holds the timestamp. So all these information will be stored in the inode, right? It is also pointing to the actual data blocks on your system, right? Whenever the disk, because the data is stored on the disk, right? It is nowhere stored in the RAM or something, right? But how that got interlinked, these inodes know, okay, where is your actual data is stored on the disk. They knows the block number, right? When you call this internally, there is are called system call, right? Strace utility. I'll try to explain what is happening when you hit all these command. Behind the scene, what exactly is happening. Okay, so these are the inodes which generally store the ownership, permission, data and timestamp, path to a data block containing, right? File allocation table keeps the file name and associated inode to it, right? So there is any other table called file allocation table, right? That keeps the file name and associated inode to the data. Now the thing is, how we come to know that, okay, what are the inode size for that, right? Because each inode will have some kind of size so that it can store all these metadata information. So here, let's say if I just run this, so on current is it is root, right? If I just wanted to see what are these file systems, so here you can see it is not printing. Let's see fs tab. So fs tab is nothing. Fs tab is just your file size or file system table, right? That is of fs tab, which will holds all the information, all the file system, all the disk and everything in this. So here you can see we have this xfs file system, right? Before rel 8 we have ext4, ext3, right? Those are kind of file systems. So similarly in rel 9, 10 we have this xfs file system, which is far better than ext4, like having a very much very big capacity to handle one big file system. It is little fast. The way it stores the data is much like good than the other file system. So this is the default file system in the rel, right? So now if you just say xfs info and this one, so here you can see this is the utility again regarding your xfs file system, what it is doing, right? How it is generating and everything and all this. So there is a parameter called I size, right? So it is nothing, it is just inode size, which is a y1 12 bytes, which will help, and the other information about this, right? So whenever you are storing anything on this XFS file system, those file systems will are storing in these inodes, and each inode will have a 512 bytes of in directory, right? Now, when we are storing these files inside our system, right? So our system knows, okay, how to link all these blocks which are sitting on disk, and that when you call this, so how it is taking me the exact data from that particular file, right? What if I need to create my own link, right? I'm 100% sure that you guys have created some kind of shortcut in the Windows file system, right? Like if you have any kind of file system which is sitting in your boot menu, or maybe in your drive, wherever you have this, is those you wanted to access from the desktop or some other file system. So what generally we do a kind of shortcut, right? So in Linux also we have something called symbolic link, and these are the two types of symbolic link we have, and we can consider those as a kind of what you say this soft link and hard link as a kind of shortcut, right? So let's start with the hard link first. So hard link is a mirror image of the original file. What do you mean by the mirror image? So generally what is happening is when you are creating this, right? When you are creating this hard link, right? So it points directly to the same inode, right? They are not a different, although they have a two different name, because that name stored in file system table, and that file system table knows the inode. So hard link stores share the same this inode. And behavior is, if you delete the original file, the data stays alive until the last hard link is deleted, because that file name, whatever is in file system table name, has the inode, right? You have deleted the file, that means that you have erased one entry from that table, but one entry is still there, right? So still you can access the inode, and if you access the inode, obviously you can access your data. Cross device, right? You cannot link your different disk or partition, because inodes are unique to each disk. You can see this, right? So you cannot do this part, because it is sharing the same inode. That is the reason it you cannot create this across the different file systems. Directories generally cannot link directory to prevent system loops. Command is just to, so ln is the command, path to the original file, and whatever the link name you are giving, so that is this your uh, uh, for this hard disk, sorry, hard link, right? So let's do one thing. Let's create we'll go to the RHCSA. Let me clean my CLN clean. Okay, so here let's say you have this file called ping.sh, right? So what I will do is I will gonna create a hard link for this. Let's say new ping.sh. Okay. Now if I do the listing, right? So what is happening is you can see that this number is now 2. So what is this? It has a 2 hard link, that means, right? So this new, if I do the same thing with this, so you can see that ping is having this inode, and new ping which we created using the ln command, which is the creating a hard link, that is also having the same inode information, right? So that is how you can see, okay, what it is. And those are similarly on the same inode. That means that whatever the data is on disk, they are pointing to the same data. Let's say you have this ping.sh, nothing is there, right? You have this new ping.sh, nothing is there. So what I will do is I am from ping.sh, and I am uh, doing this data in this. Now, if I see this ping.sh and new ping.sh, you can see that they are pointing to the same data, right? So this is the redirection, guys. We will talk about if we haven't, how you can like redirect your data from your bash cell directly to the file and everything, right? So that is how that we can create the hard link. Now, if you see that, okay, we have already seen that, okay, this is doing this. And the timestamp also, like if you have see, let's say touch command is just to touch the this ping, right? So let's say ping.sh. What is happening is now you can see similarly it is uh, updating the timestamp for both files at the same time. Okay. And if I'm gonna remove this new ping, right? So it is gonna remove it, but still you can see we have this ping sh and it is having the same data, right? So that is how that you can create and all these for this. Let's say I'm trying to create this one hard link for the my directory. What it is saying is ln hard link not allowed for directory. That's what you understood, right? Generally cannot link directories, right? Why? Because to prevent the system loops. Right? It is a kind of internal stuff, not in this. Maybe we'll talk about in our troubleshooting part. But yeah, hard link is not allowed for your directory. Hard link is allowed only for the files. Now the question is, what if I need to create a link or maybe kind of shortcut for my directory, right? So for that, we have something called soft link, right? So now ln was the command just to link the file to a particular thing, and if you are creating a soft link, then you need to pass that hyphen s as a flag, right? Now if I say this, so what it will do, it will gonna create this new proj. Now you can see this new project is pointing to this project directory, and this is the additional field, right? Because for directory, you can see it is a directory. For regular file, it is empty. For the link, you can see it is L, right? So that means that it is a soft link, and this soft link is pointing to what? It is pointing to something called project, and it is possible, right? They can point to different across file system. Why? Because they are not sharing the same inode. They have their unique inode defined, right? But there is a drawback. If you remove the original, then your soft link will be broken, right? Because it is just a path to reach to your particular original file, right? If original file is deleted, then there is no way that you cannot reach, right? So that is what that you can do. So this is how we can create this soft link for your direct, right? Like if I just go to this new project, and if you see I am sitting in this, right? But if you run this, so probably you are in the same file system where we have created this, right? Let's say I'm in this new project and I am creating a new file here, right? New file. Now I come back and I'll go to the project, and if see, you can see that it has created a new file. So it is just a path, like you can reach from here to there, right? And let's say if I am gonna delete this project rm-rf, so what is happening? You can see that color is changed. It is saying that it is nowhere. Now if you try to go this, it is not taking this new project. It will say no such file or direct because we have created, right? So there is another command called this one, and that will remove your shortcut, right? You can directly delete it, but that's not recommended. Always just try to unlink that particular what you say, this soft link, right? Now you can see that we are clear on this part. All right. So I think that was the last topic from today. So what we have discussed the identities and groups in our Linux and where those information are getting stored in our Linux. What are the utilities or the commands to deal with these identities like user add, passwd, and the password and the ch age, like change age of your uh, password for the particular user, right? What are the file permission, how they looks like, right? Maybe we'll discuss this in more detail going forward, but as of today, like just to understand what are these RWX and everything stuff, right? What are the ownership permission and everything, all those information are getting stored where? What are the inodes, right? How to deal with the inodes and everything. Then we have a few things, something called a symlink called soft link and hard link. These are shortcuts to a file. Okay. And I'm not sure. I think, yeah, we have the lab for this. If you are following along, so I will strongly recommend go and follow this lab, file systems, file inode lab, right? Number three. I think I haven't updated the lab, so I will push the lab, few more lab I have created. So those lab I will gonna push, and I recommend to go with this, right? Now, what is the next topic? For next topic, we will talk about our editor, right? Vim or Nano, maybe how you can deal with. Okay. So, all right, guys, I think that's for the day. I will meet you in the next video. I hope you are uh, liking my content for this RHCSA where we are trying to debug the Linux in more details, where we will find these details and everything. Okay. So, yep. I will meet you in the next video then. Thank you. Bye bye.